Yo, what's up, everyone? So, as promised, the final part of review is here for you Tuesday morning, and it's definitely the most important, the practice test. And I send it last, which usually means it's probably going to be the least watched of the three videos. But if you really want to get a feel for exactly what the test is going to look like, this is the right video for you. So the test is going to have 4 multiple choice questions and 2 free response, and it's going to look super similar to this test. Okay, the multiple choice on the test itself will be a mix of the questions I've already given you. So I've given you like 16, and then new questions that are pretty similar to the ones that I gave you. And then the 2 free responses are going to look very similar, just different kinds of questions, like in what do I call it? Like talking about different subjects, but very similar topics. So I think this video is going to be really holistic, really effective, and hopefully not too long. I think we'll go through it quick. But we'll start on page 1 with 2 word problems that don't give us any kind of display, which I think are the hardest. Ignore the numbers here too. Just focus on the big number I give you. So for number 1, oh yeah, wait, and also do the practice test before you watch the video so that you can really see how you would do on the real test. Okay, so look at the answer key, and I'm going to recommend everyone watch it anyway, but at least look at the questions first. So for number 1, it says that a random sample of 20 athletes has a strong linear relationship between the number of hours they exercise and their heart rate. And they tell us it's strong and linear. For the athletes in the sample, those who exercised more per week tend to have lower heart rates than those who exercise less. Which of the following is a reasonable correlation between the number of hours athletes exercise and their heart rate? So I like this question because it can trip you up kind of initially. It tells us that the relationship is strong and linear. But remember that whenever you talk about the correlation coefficient, there's 3 different aspects to that. And strong and linear comes second to the most obvious thing, which is positive versus negative. Okay, so this tells us that it's strong and linear. So it's going to be a high correlation coefficient, but it could be positive or it could be negative, okay? Depending on if the correlation is positive or negative. And to figure out which one it is, we just have to read this next sentence. It says that for the athletes in the sample, those who exercise more, so the more you exercise, the lower your heart rate's going to be. So you don't have to sketch it, obviously, but it's saying something like that, right? More exercise equals lower heart rate. So we know that this is a negative relationship, and that's why this is so difficult, because you might have been tempted just to choose A, 0.71, because that is strong and linear. But it has to be one of my negative answers. And it's not negative 0.14, and you know, it's not going to be negative 1 because it's not perfect, okay? They say that they tend to have a lower rate. It never says that it's perfect, right? And very rarely do you have a perfect correlation, and they would describe it as perfect if that was the case. Okay, so strong is anything from like negative 0.7 to negative 0.9, so that's why D is going to be my answer for that one. Number 2 is my second word problem, but I really anticipate this one being pretty easy because we've done it quite a bit. But I'm going to summarize it, so I'm going to read it in my head and then summarize. So they want to figure out how tall trees are compared to how old they are. And they took a random sample of these pine trees and gave you a line of best fit. Okay, this is good. So this one actually isn't like a blind question. It gives you some sort of stimulus here, which is the line of best fit. And then it asks us which of the following is the best interpretation of the regression line. Now, all these practice test questions I don't think are the hardest multiple choice, because I tried to give you the hardest ones before. But remember that this is super common for the AP, to ask you to interpret the slope, the y-intercept, the correlation coefficient, everything. And the slope might be the hardest for you, but you always have to just remember, that the slope is how much y changes if x changes 1. So always think x changes 1, y changes the slope. So then you just interpret it in your question. x in our case was the age, right? We want to see, does the age predict how tall it's going to be? So as the age of the tree gets, as the tree gets 1 year older, we expect the tree to be 0.48 higher. So that would be my interpretation, and I like to know that before I even look at the answers, because they all look so similar. And the height increases on average 0.48 per year. And I am rolling through these multiple choice because my hope is that we're solid. And then we'll get a little bit more depth into residuals. That's going to be the big thing I want to talk about later in the video. For 3, it says that we have a scatter plot of students' heights and their arm spans. So really classic information. And it has one point that's pretty far away from the others that they list as point A. So the question says, if this point is removed, what is going to be true? So a classic AP which statement is true, and in this case we notice every single question is talking about the slope and the correlation. Okay, really typical question for them to ask, and you could either talk about a point that exists and what happens if it's removed, or a point could be added, and that's this point. And let me tell you the big strategy, and that's to draw the line twice. Okay, just using your instincts. If this is my line, if this is a point on my graph, I can see the line is going to be something like this, right? Oh, and there's a point there too, good to know. But it's going to be something like this. That seems neutral, gets close to everything. But this point, which is all the way on the end, is much lower than what you'd expect if it was ignored, right? Even with this point, this graph without is gonna be much different. Okay, so what you need to think is that this point is affecting my graph a lot. It's affecting the correlation, and it's definitely affecting what the line would look like. So let me describe this line that I just drew as with A. Without A, it's going to be much higher. And if you get confused, and I think it would be reasonable, with which of these lines has a bigger slope, just imagine walking up both of them. And this line is much steeper. If you were to be walking up this hill, it'd be much more difficult. Okay, so without A, the slope is going to increase, and the line is going to be more accurate, right? This point was really screwing with everything. So the line is definitely changed because the slope increases. And then if we take away the point, the correlation is going to increase as well. Think how accurate all these points are depicted. And I think I kind of screwed up, like maybe it'd be a little flatter to cover these points. But I think this line is really accurate for what we have. So that is C. And all these topics I'm going through quickly, but I'm going to cover them twice in the same video. Okay, so let's just read 16. And 16 is important because there's something that could trip you up. It says, which of the following scatter plots is the correlation between x and y closest to 0? And if you have r equals 0, we know that that means there's no correlation, right? But what's really important to recognize, now that we've kind of gone through the whole unit, is that it's not necessarily that there's no correlation, as much as there's no linear correlation. Because R explains how close every point is to an imaginary line of best fit, right? So this is obviously great correlation. This is pretty good correlation. Also amazing correlation and good correlation. But if I'm looking at E, which is obviously the answer, the problem is you couldn't draw a line that represents this data at all, right? If you tried this way, you'd miss these points. If you tried this way, you'd miss these points. So if you tried, you probably would have a straight line that doesn't tell you anything. Okay? So even if you see what you would describe before this class as like correlation, as in like a relationship between x and y, remember that R describes a linear relationship. Okay, so this would have a 0 correlation coefficient. And I hope that makes sense. But we're now going to talk about the free response. And this will be the big part of the lesson. And know that the real test is going to look super similar. I'm just going to come up with new concepts. And speaking of concepts, I think I came up with some pretty good ones for this practice test. I have been watching Twitch, Disguised Toast, all of that, the Among Us stuff recently, which, you know, I guess is nerdy. I don't even know, but like, I honestly find it really relaxing just to listen to them. And sometimes, like, you know, a lot of them stream late in the day when I still have to do work, but I'm tired, unlike the morning. So, you know, I'm pretty pro Twitch right now. That's something I've kind of discovered recently. I've been on a bunch of like binges over quarantine. Like I had a TikTok a TikTok phase for a while, but yeah. This question's about Disguised Toast and his number of streamers in October. And the general gist being that within the past month, like Among Us has been really popular, so the number of streams everyone's gotten has improved a lot. Right, so at the beginning of the month, people were less well known, but by the last day of the month, you know, he was getting quite a bit of streams. So that's what the scatterplot shows us, and then the way that it's going to give us the data is through computer output. And let me just, before we even do the question, let's rewrite my computer output. And again, we're only looking for R or R squared and some way to write the line of best fit. And I feel like I've explained this a lot recently, and I think that's good because the unit is not that complex, right? There's not too many things. So we look for the coefficients. That's going to be our line of best fit. And the constant's the y-intercept, the outside number, and then the x value is connected to this coefficient, right? So x is days of October, and the coefficient or the slope is 725. And if you ever got lost, this is an example where you could look at the graph and see that the y-intercept here, when it's 0, is close to 5,000. So it's definitely this number and not this number. And that's my line of best fit. And we know we have R. And we might need R squared eventually. So now let's go into the question. The first question says, what % of the variability in the number of views can be determined by what day of October it is? And we remember here, wait, let me just drink some water. Okay, so remember that if we see something like what percent's a good hint, or variability, that we need to convert my R value into R squared, which is the coefficient of determination. So not always will it say determined somewhere, but it will always say variability, okay? And we know that to do that, we're just gonna square this number. So if R squared is 0.391, that means 39.1% of the variability can be determined by what day in October it is, which isn't crazy high, right? But what we're going to notice is that there is, you know, this point that's affecting my graph quite a bit. And this R value and this R squared would probably be a lot higher without it. B is covering the other thing it could really ask you to identify and interpret, and that's the y-intercept. We know in this case that that's 4379. But let's talk about what it means in this question. It's always what y equals when x is 0, right? And in this case, x equals 0 means that it's the 0th day of October. So I think that maybe this particular question, that could be hard to understand, but that just means the day before October, or like September 31st, or September 30th, I guess. So if you didn't write that entirely, that's fine. But if you really wanted to interpret it in the context of the question, that would mean that on September 30th, he would be expected to have 4,000 viewers on his stream, or the day before October starts. So moving right along, C is asking us to circle 2 points and calculate those residuals. So again, let's just look at the x values. we have 11 and then around 1200. So 11, 1200. And then 20 comma 39, 500. So a really big number, so you know it's going to be the outlier. And remember that all a residual does is it calculates how much a point over or underperformed. So even before we do it, you know, this residual is going to be really close to 0. And this residual is going to be really, really big. Okay? So we have to use observed minus expected. So we know that this point, just to visualize it, was 39,500. But we have to figure out what's expected on the 20th day of October 1st. So I'm just going to plug both my values in. Okay, so we have my two expected values, and again, that's what it equals at the line. So to figure out the residual, I'm just going to take the data point minus each of those line values. So this is going to be 1250 minus that, and this is going to be 39,000 minus this value. Okay, so here are my two residuals. Let me just show them, and then we're going to go to D and E, and both of these are typical questions, so let's read them before I'm just going to talk about them on the other page. And both of them, just like that multiple choice question, are talking about what's going to happen if we remove those 2 points that we just circled. We want to talk about the correlation, but then also the slope. So we'll start with the point that's close to the line, okay? And remember that this point, I call it a good guy, because it's contributing to my line of best fit being really accurate. If every point was like this point, the line would have perfect correlation, right? So if we take this point away, the line is still convincing, but it's less convincing. So the correlation will go down if you remove a point that's good for your line. But the line of best fit isn't going to change. Because think that this point wasn't swaying my line either direction. Only those points that are far away are swaying the line. Okay, so remember, taking away this point doesn't do anything to the line, but it's going to hurt the correlation. And then we already did something really similar to this before, but this one I think is a little harder because the difference is more subtle. And the reason is we have more data points here. This is like a pretty big number of data points. And just so you know, like, I think this is one of my most accurate questions ever, even though it's still made up data, because this point's supposed to represent the day like AOC played Among Us with everyone and how the streams were crazy that day. And it was October 20th actually. So think that, you know, on a typical stream, the streams are increasing, but there was that one day that really went off. And we want to figure out how is that affecting my line. And what could be hard here is that if you do the classic strategy of remove the point to look what happens, the line still looks pretty good. Okay? This line still looks good. But it could be better. And what I want you to realize is, where does the line look good and where does the line look bad? The line is pretty good on the left side, right? We have points above and below. That's a good indication. But look, all of the points on the right side of my graph are below the line. Nothing is above it. And that's because this point is way, way above it. Think that this distance probably equates to all of these distances, right? Because this is just pushing us up. So if you were to remove this point, you can imagine that the line is just going to pivot down a bit. Be pretty similar on the left side, but change on the right side and just be a little lower. Okay, so what's happening to that slope? If you want to think about it like you're walking, this is a little bit steeper than the new line, which is more like you're just walking on a flat surface. Okay, so this line has a bigger slope, and if we remove the point, the slope is going to decrease. Okay, so there isn't a right or wrong or what I should say is there isn't like a formula for knowing if the slope is going to increase or decrease, because we removed a point last time too, and that actually increased the slope. It has much more to do with where that point is, and you just have to think logically. Okay? And the correlation is going to increase if we remove it because the line is going to be relatively close to every point. And my feedback has been the hardest part. Except for maybe the second question, which is going to talk about residuals. So this is the last topic, and on the test itself, at least part of this is going to be extra credit. But this question is going to be shorter because each question is not as much math. At first, you even notice they don't even give us any data at all, no statistics. This question is, we have a classic two scatter plot example, and the two variables we're talking about, or the big variable we're talking about, is upload speed, how long it takes me to upload a YouTube video, along two variables, how much memory I have on my laptop, and then also how long the video is. And this question is also kind of true because I finally discovered like one of the big problems with why the videos were taking so long to upload was the memory on my laptop. If I didn't have a lot of memory, it took forever to upload. And it's still not perfect, like this isn't really true, it still takes like 8 hours. But this question is inspired from the truth. The longer the video, the longer it takes to upload. But then if I have a lot of memory on my computer, it just runs faster. So that's just advice if your computer runs slow. Delete some stuff. But yeah, let's just do A, B, D, and C. But in the right order, so A, B, C, then D. For A, it says predict the correlation coefficient and the coefficient of determination for the scatter plot on the right. And here, we're asked to predict what the correlation is going to be. And on the test, if I were to ask you this, there's a range of numbers that would be acceptable. And I also might ask you to describe it, because I think describing is probably the most important thing. And if I was to look at the scatter plot, this is like a strong correlation to me. And it's positive because it's going up. And then you always convert the words to the R value and not to the R squared value. That's really important because the R squared value is always going to be a little lower than you would expect. So R here, if you did it on your own, I would accept anything in like this range and probably would have done 0.7, maybe 0.8. And then whatever you did here, you just have to square it to get your R squared value. So I guess the range of numbers that would be acceptable is anything 0.55 squared to 0.85 squared, which I guess is going to be like 30 to 70%-ish. So that's A. And then the rest of this is talking about residual plots, okay? So B says, which of the following scatter plots shows nonlinear regression? What type of function would better represent the data? And remember that we're not going to have to do a whole lot of math related to nonlinear correlation, but we do have to recognize if it exists. And the best way to do that is to see if you curved a line, would it make your data set even more accurate? And in this case, no, right? You couldn't really curve this in any way that would better represent the data. But here, you absolutely could, right? It appears that it's going to like really reach a point where no matter how much memory you have, it's going to take around 5 hours. So think that this is nonlinear, and on the test it'll be exponential pretty much, or trigonomic, but I'll probably make it exponential. So if you wrote exponential or logarithmic, anything like that, you would get credit here. But it's not going to be too hard because we all do come in from different places in this class. So C, I anticipate maybe being a hard question because it's almost a trick question. But what it says is describe what the residual plot for the scatter plot on the right would look like. And on the next page, I give you what the residual plot for the graph on the left is going to look like. But we have to talk about what would happen to a residual plot if our data is linear. And remember that what the residual plot tells us is where are all the data points in comparison to the line? Are they above the line? Are they below the line? Are they on the line? And if you have a linear relationship, the gist is that the points are going to randomly be above and below. There's not really any way to tell where the points are going to be. Compared to here, where you notice these points on the left and right are above, and everything in the middle is below. So what's hard about this is if it asks you what the shape of a linear residual plot is going to be, it's not going to be linear, it's going to be random. And the way you could write that is there's no pattern or that it's random. And anytime it's nonlinear is when you would see a pattern. Okay? So if it ever asks you about a linear, that could be difficult, but the residual plot would show no pattern and be random. And then this is unfortunate, but it's on the backside for me. But it gives us the residual plot for the left one. And if we're going to look at it, just what I was saying before is the pattern. It's still going to look curved. So if you have a curved line of best fit, curved set of data, your residual plot's also going to be curved. Not the exact same way, but it will be curved because the points on the left and the right were above 0 and the points in the middle were below. So on the test, I might make you do a residual plot for extra credit, but you definitely need to be aware of how they're made. And remember that the way they're made is every single residual is calculated and then plotted. So what this question asks, which is definitely reasonable, is that the scatter plot is missing a point, and we want to plot that point on my residual plot. Okay? So it says the point 25,7, or this point, isn't on my residual plot. And we notice that there isn't a data point here, right? So we want to fill in or add one more data point to my residual plot. That's for 25,7. And it's not 7, right? What we have to put here is the residual. So all we're going to do, and it gives us the formula, is calculate the residual for this data point. The data point was 7, and we're going to plug 25 into the equation. So the expected value was 8.925, which makes sense on my graph, right? It looks around 9. And if I want to find that residual, I'm just going to do 7 minus that. So this is what we put on the graph. And again, if you had to make that coordinate, it's the x value and then the residual. Okay, so 25 and then around 2 below the line. So that point was missing from the residual plot, and you could have to draw every point, but it's really, really tedious. Alright, so that video went a little longer than I expected, but I think it was good stuff. If you watched the review, I appreciate you, and I think the test won't be too bad. Alrighty. Woo!